Hey everybody, Pete here with Team Cosmos. I want to talk a little bit about Grond. This is a 12-pound robot I built for the last AVC in September 2018. Built it with all parts that I had on hand except for I think a couple belts. But all the titanium, the aluminum, the wheels, the motors, the batteries, the ESCs, the radio system, the stuff I already had here. I built it super quick. I think the time from cutting the first part to finish was under 3 weeks. Wasn't much fun. Don't suggest that for anybody. But it is a two-wheel drive wedge bot looking thing. There are some interesting aspects of this that I want to get into here, so let's dive in. Alright, before I go further actually I want to talk about this poster in the back. It's not quite appropriate in today's time and age, and actually when I bought that I was doing it ironically because when I was a kid old guys always had pinups in their garage, and I always thought it was funny and a little weird. So when I was in my 20s I bought that poster, put it up in the garage thinking it was ironic, but now I realize I'm an old guy with a bikini girl in my garage, and I don't think people get the joke anymore. I've just turned into one of those guys I was kind of trying to make fun of in the past, so it's a little weird and I should take it down. However, it's been up in my garage for 20 plus years, so it's a little hard to take it down. So a little torn on that. That's what the story is with the poster. So that's kind of how she drives around currently. Let's start taking things apart, taking a look how this is all set up and go in a little bit more detail. Alright, so what's going on here? This is an 1/8 inch thick titanium plow, obviously based off the D2 kits. Waiachi made it for me. I shipped them the material, but they water jet cut it and bent it. And one interesting thing I did here was I had them weld on some support here just in case I was worried about horizontal spinners. As always, wanted to stiffen those up. I never really got to test that out. I like the idea, but who knows if it's worth it. The reason it's so fast, of course, is because of these giant magnets here. Each of these magnets gives me about 20 pounds of downforce, theoretical. I haven't measured it, but doing the math of the distance from the floor and all that, and it feels roughly like 40 pounds. Here's the battery that we recycle out of 60 Seconds of Glory, Waiachi switch, some interesting electronics down below we'll get into, and then I'm using 2 Vesks for drive. And while that may seem like overkill, let's open this up and take a look at the drive motors. Now these are large drive motors, kind of, well, very ridiculous for a 12-pounder. In fact, I probably could still handle the same amount of magnetic downforce with much smaller motors, but these are what I had. These are Racer Star 6368s, so completely massive motors. They're 280 kV, I think roughly 2.5 to 1 reduction or so. The interesting thing about these motors in particular is that they're sensored, so that's why I can get so great low end sensitivity from these. I can really move the robot slow. A lot of times with brushless motors it's really hard to get them going, so you end up having a lot of power right at the beginning. So completely ridiculous for a 12-pounder. It was part of the fun of building this thing. Alright, let's take a look at the bottom of this. Take off this base. Well, actually I'm not going to take this base plate off. There's way too many screws in there. The thing I want to point out is right about here there's a gyro. Actually it's a 9° of freedom inertial unit. It allows me to detect how much I'm rotating. It allows you to detect a lot of things. I actually think it's 10 degrees of freedom. But the important part of that is that it allows me to understand how quickly I'm rotating. So if one wheel has better traction than the other, or one wheel starts up a little faster than the other, I can compensate for that and speed up the other wheel to try to drive in a straight line. The problem with a two-wheel design always is they're hard to drive in a straight line. When you have this kind of power and this kind of downforce on any kind of bot, if you want to go fast, it's going to get squirrely. So the theory was I could use some computational power and gyro sensing to understand how straight I was driving and straighten things out if I started to get a little bit astray. The next thing that's worth talking about is that I do some interesting mixing. I could have done a lot of this mixing in the radio, but once you incorporate that gyro in here, you're going to have to do some math and things like that. So I had to end up doing my own mixing, and it gave me an opportunity to do a few things that I can't do on my radio. Maybe some of the more modern radios can do it. let's get this up off the ground. I'll see if I can demonstrate here. So if I turn this back on, the top speed of this thing is like 30 miles an hour, something completely ridiculous. And so I knew I didn't want to dual rate it all the way down and lose that top end, because the idea was I'd catch somebody up here and utterly destroy them into the wall. So the theory is that I have a certain amount of range on the controller and a top speed. And so right about there is my top speed, unless I pull the trigger all the way and then you go into turbo mode. So let's see, I'm going to hold this. So there it is. And then so you can hear there that there's a distinct break. So that allows me to have most of the range of my trigger and have kind of smooth control at lower speeds. And then once I have them up on the wedge, then I pull the trigger all the way and really give them hell. That's the theory anyway. All right, in order to make this configurable, I came up with a few modules. These are not things that would ride around in the bot normally, but I can plug these in to my little custom electronics down there. This is a radio unit that will allow me to talk to another device, which has this USB plug. So I plug this into a laptop, and then I can get telemetry from the bot and make adjustments. I'll demonstrate that real quickly. So here I have all the electronics hooked up, the radio unit's working. I can type commands to the robot and get a feedback. So if I want to see what commands are available, I can type help. It gives me a little printout with all the different variables I can change, and abilities to read the current settings, display them on screen so I can see what all my variables are. Looks like I have 8 or 9 different variables I can play around with. And then there's other outputs I can put. So I can look at the PID loop, I can look at the motor output, or I could look at the gyro settings. And you can also plot those out. So let's take a look at what the plots on these look like. So here I've switched to looking at the motor outputs. So you can see the different acceleration values there. And you can kind of see the turbo stuff pop in. See that turbo jump up when I hit that threshold on the trigger, and you can configure all the thresholds and max turbo speed and max non-turbo speed and all that kind of stuff. Similarly, you can plot out the gyro input. It's pretty sensitive. If I tap the desk, you can see it start to read. And if I zoom out a little bit, I can. When I start moving the robot, you can see the readings come across. Hopefully that shows up. Might be a little difficult to see, but that's basically how I get the different signals in from the robot to see how it's rotating. I only have that one Z rotational variable coming across, but kind of a good way to see it visually. So how did all these things work out and come together? I got it done just in time. Had to make some compromises toward the end, just run out of time. One of those was to use these plastic pulleys. I was suspicious they'd fail, but they failed a lot more quickly than I thought. It's kind of embarrassing in hindsight to look at this and go, how did I even expect that to work? And worse of all, I had metal pulleys, but I didn't have time to broach them properly, so I never got to use them. So most of my fights I lost, or a lot of the issues I had, was due to these plastic pulleys stripping out. The gyro functionality, while it helped, I didn't have time to really tune it in. I just was simply out of time, long hours, right up to the last minute of the competition, which is never a good idea. So while the gyro helped and the logic helped, it didn't really solve the problem of going off to the side. That said, overall, I think it was a pretty successful approach or attempt at some of these new ideas. I think they're worth pursuing, spend a little bit more time on. In this bot, maybe a different bot. It's always hard to refine an existing bot when you have an idea for the next 3 bots that you want to try that incorporate a bunch of other wacky ideas. So we'll see what happens. This one might sit on the shelf for a bit, or next time ABC rolls around, maybe I'll get it out on the test bed and refine some of this. So that's about all I got. Thanks for watching.